All right, we're supposed to use a graph to find the real and complex zeros of the function. And it sounds like you're good at graphing the function, looking for our x-intercepts, and realizing that those are going to be our three solutions. Now, with this one, those first two aren't really nice numbers, but this last one over here is. What we can do is use synthetic division to kind of help break up or start to factor this function g of x. Now, how we do that is, since 1 is one of the x-intercepts, I'm going to use synthetic division with 1 on this polynomial. So I'll take all those coefficients, 1, 1, -3, and 1. We do our synthetic division, bring down the 1. 1 times 1 is 1, that'd be 2. 2 times 1 is 2, makes -1. 1 times -1, -1, and there we go, there's 0. All right. Now, what this synthetic division did for us was give us two factors. First of all, it said that one factor is right here. It comes from that 1. That means that g of x has one factor of x minus 1. Now, the other factor is this one. What came from our synthetic division, that result of 1, 2, -1 is 1x squared, plus 2x minus 1. Okay. Now, that should answer your kind of overarching question of how do we use synthetic division to get that quadratic. That's really how. It really falls along the lines of, let's say that we had a number like 20, right? And we're trying to factor it, and we realize that 2 goes in there. To find another factor, we would say, well, what is 20 divided by 2? And we say, oh, that's 10. So now we could rewrite 20 as 2 times 10, right? It's the same idea that once we know what one factor is, then after we divide that factor out, what we're left with is going to be another factor. To finish this problem off, if we're going to identify those real and complex zeros, well, we take each of our factors and set them equal to 0. So if x minus 1 is equal to 0, that would mean that x is equal to 1. Right? That's our real solution, the one that we saw from our graph. But using that quadratic then, the x squared plus 2x minus 1, we set that equal to 0. We know it's not going to factor nice, otherwise we would have got nice x-intercepts. All right, so we're going to use quadratic formula. X equals -b plus minus square root b squared minus 4ac all over 2a. So that'd give us what? -2 plus or minus square root of 8. Square root of 8 is 2 root 2. And we divide everything by 2, and we get x to be -1 plus or minus square root of 2. Right? And those are our other two solutions. When it came to problem 3, there was a little problem with the original worksheet. That when I was writing it, I had a different function written down on my piece of paper. But if you notice, the function here, h of x, is exactly the same as f of x on the worksheet. So what we did is we changed h of x to be this. This h of x is x cubed plus 8x squared plus 25x plus 26. Now, if you want to pause this video right now, give it a go just like the last one, graph it, look for any nice x-intercepts that you got, and then divide that out. You know, that'd be a good idea. Okay, now if we're going to go through this together, we're going to graph it first. So you type it in Desmos, you get a graph that kind of looks like this, where you notice there's only going to be one x-intercept, and that happens at -2. So let's use synthetic division with that -2. Okay. So we're going to go with 1, 8, 25, and 26. Bring down the 1. 1 times -2 is -2. Be 6. 6 times -2 is -12, which makes 13. 13 times -2 is -26, and there's 0. So when we're rewriting our h of x, we have our two factors. One of them comes from here, and one of them comes from here. So we can say that h of x, from that -2, Our one factor is x plus 2. From the 1, 6, 13, that's our quadratic, x squared, 1x squared, plus 6x plus 13. All right? That's the big deal of getting it factored into a binomial and a quadratic first. And now we can go ahead and solve the function, finding those zeros, by setting each factor equal to 0. So obviously if x plus 2 is equal to 0, that gives us our first solution. X is negative 2. Right. Now for the second one, if we take that x squared plus 6x plus 13 and set it equals 0, it's not going to be nice. If it was, we would have saw it on the graph. So we have to use quadratic formula. X equals negative b plus minus square root b squared minus 4ac all over 2a. And that gives us negative 6 plus or minus, let's see, 36 minus 52 is negative 16. So negative 6 plus minus. Square root of a negative is I, square root of 16 is 4, so that's going to be 4i all over 2. And then divide each of them by 2. So we'll have negative 3 plus or minus 2i. And there's those two solutions. In problem number 4, that was another one where it just didn't work. The one that I had on the worksheet didn't work. So we said to change it to k of x is equal to 3x to the fourth minus 13x cubed plus 91x squared minus 29x. So if you want to pause the video, try this one on your own. Feel free. Okay, if we graph the function, we'll get something that looks like this. And we're going to see two real x-intercepts. One of them is at 0, and the other one over here is at 0.333, which of course is 1/3. Now, if 0 is an x-intercept, that means that x minus 0, or just x, is a factor, which when we look at k of x, it should be pretty easy to factor out that x. So let's just do that right away. If I'm just going to take out the x, then I'll be left with 3x to the third minus 13x squared plus 91x minus 29. And now we're going to have to factor out that 1/3, but we're not going to do it out of everything. We'll just do it out of just this cubic part. So when we do synthetic division, I'm going to use 1/3 in my box. And my coefficients are 3, negative 13, 91, and negative 29. Now, when we do that, bring down the 3. 1/3 of 3 is 1. That would make negative 12. 1/3 of 12 is 4, so we're at negative 4, which makes 87. Oops. All right. 1/3 of 87 is 29, so we add them together and we get 0. Terrific. So that means that we've got k of x was x times all of that, but now we got x times our x minus 1/3. And this part, the 3x squared minus 12x plus 87. And I don't know if you'd see this or not, but every one of these coefficients in here are divisible by 3. So what I'm going to do is factor out a 3 out of there as well. So we'll have 3x, x minus 1/3. And then divide out a 3 out of 3x squared, we got x squared. Divide a 3 out of negative 12x, we got minus 4x. And divide a 3 out of 87, that'd give me 29. Okay. Now when we're trying to find all of our real zeros, one of them is right here. 3x equals 0 means x equals 0. And one of them comes from here. If x minus 1/3 is a factor, then x equals 1/3 is a solution. All right. And there's two of them. The other two are going to come from our quadratic. So we're going to have to use quadratic formula. X equals negative b plus minus square root b squared minus 4AC all over 2A. Now, 4 times 29 is 116. So 16 minus 116 leaves us with negative 100. All right, so we're at 4 plus minus. Square root of 100 is 10. Square root of the negative is I. And we divide everything by 2. And we get our other two solutions, 2 plus or minus 5I. All right. I hope that video helped explain a couple things. I'm sorry for the errors that I made while I was writing the worksheet. I'm sure that was pretty confusing, but let me know if you need any more videos explaining anything else. See ya.